Okay, so we're gonna make a flavonoid standard curve, and so these are flavonoids specific for spinach, but the concepts that we'll use are exactly the same for really like any group of compounds. So the first thing we're gonna do is we're gonna go get our spinach flavonoids. So we're gonna walk over to the -80. So we have some stock solutions that are already prepared. And so we had weighed out these flavonoids. They come as a crystalline powder. So we had weighed them out. We had created like, 0.1 mg per mil solutions or something like that. And then we had aliquoted them. So that way when we, oh, you guys scraped the -80, looks nice. That way when we get to this stage, it's much easier. If you want, you can come around I guess like the location stuff is variable, but let's see. These tubes. Yes. Okay, so we have these. We have this box of flavonoid stock solution aliquots, and so each aliquot has about 40 microliters worth of some kind of stock solution in it. So we can grab each of these stock solutions. And for convenience, I usually keep the active ones at the top so we don't have to like dig through. But like each set of rows is a unique flavonoid standard. You can see here we've got, 0.1 mg per mil spinacidin. Putting metal tweezers in here was not my best idea. 0.1 mg per mil patuletin. Burning my hands. 0.05 mg per mil jacidin. That one's kind of hard to dissolve, so we had to go at a lower concentration. Quercetin 3-glucoside. This is what we quantify everything to. Oops. And I believe this is naringin or naringinin. Naringinin, 0.1 mg per mil. Okay, so that's our big five. So the one thing I'm just going to double check is just make sure we have, that one looks good. Just make sure we have enough in there because we do reuse these to a degree. Should be fine. A little foggy, but I think that's enough. That's enough. Okay, terrific. So I'll put the top back on, I'll put this back inside. All right, we'll head back over. Oh, could one of you guys grab the that like tube of 20 micromolar taxafolin? It should be back in the -80. Okay, so we've got our 5 stock solutions here. So what we're going to do is we're going to mix these together because what you could do is you could have a standard curve for each analyte, but it gets kind of that just becomes too complicated at a certain point. So what we do is we make kind of like a cocktail out of them, where we have multiple together because our analytical method is able to separate each molecule, so we can run them all together. So we have, what I recommend doing is creating a set of 4 ml vials ahead of time. So these, you can just label like your stock solution, your 3-fold dilution, your 9-fold dilution, all the way down to your 6,561-fold dilution. So we're going in threes. So what we're going to do is we're basically going to create a stock solution and then take a third of that and move it into the subsequent vial, take a third of that, move it into the next vial, and so on and so forth to create a serial dilution. One thing that can be helpful, I'm not going to, I don't know where the other one went. So we have some 3D printed, oh yeah, here it is. We have some 3D printed like vial organizers that you can use. Sometimes that's kind of nice to have. But yeah, if you're working quickly, you might be able to just kind of like do everything in here in the rack. so let's get our P1000. So the first thing I'm going to do is I'm going to actually prepare all of the subsequent vials. So because we're moving a third of the stock vial into the next vial, and then a third of that into the next vial, we do everything out of 900 microliters just to make the math easy. So what I'm going to do is I'm going to put 600 microliters of our solvent, which is 1-to-1 methanol to water plus a little bit of formic acid. I'm going to put that into all of these to prepare them ahead of time. I think if memory serves, it's not really 600. I think we're going to do, yes, 576 microliters. So we're going to go 570, 246. And so that's going to allow us to add in a little bit of taxafolin.
Yeah, that one's perfect.
Oh yeah, that's fine. That's okay. Yeah, this is perfect. Yeah, we just need the one.
Okay, I can
Thank you.
that.
Okay, so we use this 20 micromolar taxafolin because this helps us correct for instrument variability. So sample to sample, and especially like day to day, the instrument is like kind of all over the place. So we add a standard amount of, it depends on what method you're running, but in the case of flavonoids, we tend to use taxafolin because it's not commonly in a lot of fruits and vegetables. So this kind of helps us correct for instrument noise that might occur just from fluctuations day to day. So, all right, so we've got our pipette set at 576, and we're going to add our 1-to-1 water and methanol into our vials. And then we're going to add 24 microliters of this taxafolin to each of these vials. So it's going to total 600 microliters. Prime it a couple times just because this is 50% methanol. And in my head, I'm just counting, like just to keep myself like on track where I'm at with these vials. The other thing you can do as well that is fairly straightforward is just to kind of like look down before you pipette, and you can kind of tell like an empty vial from a partially filled vial. That always works too. Okay, so I'm gonna get a P100. And we're going to set this one to, oh, this was on 25, very close. We're going to set it to 24. And we're going to add our taxafolin, which again is our internal standard that we're using to correct for any instrument variation. Again, I'm just priming a couple times. I'll just pick up the amount that I need, and then I'll just put the tip on the side of the vial and expel it. Okay, so we just did we just prepared the subsequent vials that we're going to use. So all of these have 600 microliters in them now. So this one is going to have 900 microliters total, right? So instead of 24 microliters of taxafolin, we're going to add 36. So it kind of makes sense. It's 50% bigger, but it's the same ratio of like liquid to taxafolin. Got it, 36. right, so our taxophilin is all done. Would you mind putting this? Thank you, sir.
Yeah.
Thanks, Alex. Okay, so we've got that done. So now what we need to do is actually prepare our stock vial with the rest of our, like our actual standards. So we use 30 microliters of each stock solution. So I'm gonna turn this down to 30. I'm gonna get a new tip. Alright, so now what I'm doing is just adding the actual stock solutions in. So what we can do is just kind of one at a time, and I'll just use this organizer just to like help me remember which ones I did already, so I don't accidentally double dose anything. So yep, we got it set at 30. So that was 30 microliters of spinacidin. 30 microliters of pachaletin. Now 30 microliters of jacidin. Microliters of quercetin 3-glucoside. Again, this is the one that we're using to quantify everything against, since they don't sell standards for spinach flavonoids, at least the glycosylated ones. And then the last one is arginine. 30 microliters. Awesome. And one thing I'm doing kind of like between vials is I'm also just taking a peek at the window here, because sometimes like what'll happen is the volume can like drift over time. So just kind of make sure that it's staying at the volume that you want it to be at. I think what happens is the little volume adjuster knob is like right where your fingers are. So when you push down, sometimes if you like twist a little bit, it'll move your volume over time. Okay, so we've added in our 36 microliters of taxophilin and then our 150 microliters worth of standards that are at a known concentration. And so now all we need to add in is 714 microliters of 1:1 methanol to water. 12, 14. Okay, so now we have our stock solution is fully made here. So we've got all of our standards in there. We have our internal standard, our taxophilin, and then we also have the correct amount of 1:1 methanol to water to dilute it up to 900 microliters. So now we have 900 microliters here and 600 microliters in all the subsequent vials. So we're going to bring 300 microliters over from this into this, into this, into this, and this. And we're going to serial dilute and create our standard curve. And I recommend when you go into each new vial, just pipette up and down like a set number of times. I usually do 4 times. That just kind of ensures that everything is getting mixed nicely. And the last one, you can just kind of mix it a couple of times and inject everything into it. Okay, so I'm just going to put our caps back on, just temporarily. So one thing that I highly recommend doing in advance, and Alex, thank you for doing this, is getting your tubes set up ahead of time. So what Alex did was he created like a label sheet so that he could quickly label all of these tubes. So we basically have, we have like 6 copies of the stock vial, and then we have 6 copies of the 3X vial, and so on and so forth. And so this allows us to just do, like, this process, takes a little bit of time. So instead of doing, we have to run a standard curve every time we run a new batch of samples. So instead of doing this whole process, every time we run a set of samples, we can basically just do this once, and then we at least get 6 runs out of it. If you guys have any questions, feel free to chime in at any time.
Okay.
600 divided by 6. So I think. So I'm gonna set. Actually, I'm gonna get a different pipetter. Yeah. Let's see, what's this? That's 100. So I'm going to do 90 microliters in each one. So get our 90 there. So yeah, in theory, we have 600 microliters in each one of these 4 ml vials. So we'll have enough material to distribute here, and then we'll have a little bit kind of left over. Or just some is just going to get stuck on the walls and whatnot. So, all right, so we'll start with our stock vial. And again, the concentration is set at this point. So, if you get a little bubble or something, you don't have to worry about it too much. But yeah, try to be as accurate as you can. Yeah, and you can see, so I just finished the 6th one, and you can see there's just a little drop left over, not really enough for a full vial. Okay, we'll get a new tip. And if you want, if you come around the other way, maybe that would be a good angle, or no?
The other way was working fine, but
okay.
This also works.
Yeah. And again, I'm just counting in my head just to keep track of where I am. Okay. And at this point, we've done 2 rows, so I'm just going to start putting some caps on, partly so that they don't evaporate, but also just so I can kind of tell where we're at in the rack, because the first couple rows is easy, but once you start getting into it, it's a little tricky to keep track of where you are. One other thing to keep in mind too with these insert vials, sometimes you'll get a little bubble at the bottom, so it's good to just, you can see there's a big bubble right at the bottom there, so it's good to just kind of flick it. When we inject this on the system, the needle's going to go down into the vial, and if it hits that air bubble, it's not going to get an accurate injection.
Go.
Okay, so now that we've added our our standard mixes to each one of these vials and cap them and give them a couple flicks to make sure the air bubbles out. We can start storing, we can prep these for storage. So each one of these rows is basically its own standard curve now. So at least in the container that we have here, we have room for 5 standard curves, and then luckily we're running a set of samples today, so we'll use that 6th one. So we just want to add those into here and then label our box so that we know what it is, the date, who made it, what's in it, and then what solvent it's in. So that way we can, backtrack if we need